Well, good afternoon, Tom, and thank you for allowing me into the lab. We call it the lab, this meeting with our team leaders. We're waiting on Farbod. He may join us, but in the meantime, we have David with us, one of the other team leaders. Since Tom's audience is growing very rapidly, I thought I would give a little bit of a background as to how this all started. Um, and also the transparency for CUSAC. Transparency is important to CUSAC, Tom's Center for the Unification of Science and Consciousness. It's a nonprofit organization. So let me refresh our physics community and CUSAC supporters on the beginnings of the search for scientists to conduct these experiments Tom has designed. It was a worldwide search, and several members of the MBT community from various professional backgrounds had connections to those who had the knowledge and the equipment to perform the first of these experiments, having purportedly performed many experiments like these before. Many said we already know the results or we're not interested, and such things as that. We've conducted this type of experiment many times before. Tom's experiments are available on YouTube. The charts contain all of the specific directions and information needed to conduct the experiments. They're carefully and transparently set out. Each experiment is up on his YouTube channel, and the charts for each contain all the information and steps, like I said, needed to perform them. The execution of these experiments has precise steps in precise order and have proved a little more complex than originally thought. More sophisticated equipment was brought in some cases, and in one location, um, the equipment was already there. So, just for the non scientists and physicists who first commented on their simplicity, I would like to conclude that they have not done this type of experiment before, nor can they predict the results because of the way it's set out. And that's just something Tom can address. One team was fortunate to have a postdoctoral candidate who is progressing favorably, but had a timely contractual obligation and had to return to her home country before completing the experiment. That's just some of the things that come up in situations like that. Now, to be fair, those conducting the experiments are from the academic community. They have time constraints, revolving assistants with insufficient experience and knowledge, and such things as this. So, hello, Farbod.
Oh,
I'm
hello.
so
I'm
I'm
sorry.
so glad you're
Yeah.
here. I was looking forward to seeing you.
Oh,
I
thank
would
you.
like
Sorry.
to offer both you and David my respect for the untiring dedication to seeing these physics experiments, which are variations on the double slit experiment conducted and the results published. Your curiosity, both of you, and open-mindedness approach to know how our reality works is really a rare quality. So my question is, in conclusion, I'm sorry you missed some of the points. I was refreshing the audience on some of the beginnings of this. So the question is for our audience, where are we going from here? Tom, if you'd like to take over.
I think even the bigger question is when will we get the first results? And this has been a terribly slow process now that's gone on for, I guess I can say, years. And it's been very frustrating watching it, get closer and closer, and then something happens, and then you're back to the beginning again. But the last time we didn't actually go back to the beginning. We've just had several problems with personnel, getting people, to do the problem. The professors in charge are busy and teach classes. They are in charge of things otherwise at the university. There are important people there. And this is done on the side for them. This isn't part of their main schedule. So they are going off on the side. And they agreed to do that, to go off on the side, but the side sometimes gets pushed back to the back burner. I think we've had some of that gone on, not intentionally. It's just the nature of things. So patience is the requirement that we need. We do have competent researchers going on in two universities, and we are gaining on the problem. in both, but it comes in fits and starts. And when we really have people together and people are working, wow, we make a lot of progress. And then, like the young lady who had to go back to her country, then everything falls on the floor until the next semester rolls around when they can get somebody else. So in an academic system, you're locked into semester. Reality comes in chunks of semesters. And if you get something that falls apart in the middle of a semester, you pretty much have to wait to the next semester before you can find people to do it. So those are the kind of problems that we've been having. More management and organization issues than really scientific issues. The science is pretty straightforward. The experiment is not easy. It's conceptually very simple. And I thought it would be much easier than it turned out to be. But now that I think about it, it's obvious that when you're measuring things in terms of nanoseconds and you're looking at individual, photons of light and seeing what it is they do. Of course, they only travel 186,000 miles per second, and you're looking at them in a lab that's probably 10 or 15 feet, from one wall to the next. So you can imagine there's some challenges in setting this up and getting all the equipment to work together and collect all the data you want. So we've never stopped. I would like for David and then Farbod to give a little talk about their kind of team leaders or group leaders for each of the two experiments. I'm kind of the general overseer, and they're the people that actually go into the labs and make sure what's going on. So, David, tell us a little bit about where we are and the big one. When do you think we might get done?
Thanks, Tom. So I was expecting August of last year, and like you said, we had a great graduate student working on it. The teacher supervisor was a side project for him, supervising the student, and we're going at doing great progress every month. And then we reached the end of the summer semester, and the graduate student had to go back to their country and find someone else. So it took like 3 months to find another student who started working again on the experiment, understanding the setup. And now it's starting again to progress. So hopefully we'll have the time to make progress during the winter semester, and it will continue during summer. So hopefully in a couple of months we'll have progress. I can show you progress. I have a lot of pictures. I'm going there often taking pictures. So I'll share my screen if I can. So this is experiment 1 that we're trying to do, Tom's experiment 1. So, it looks simple in a diagram like that. There's a source, there's like 2 detectors, 2 recorders, 2 slits, and a screen. Should be easy. Then we go with like more complex diagrams. We add some maths into it to make it work properly. And then we go into the equipment. So I can show you a bunch of pictures of what it really looks like. It doesn't look like these are pictures we took of the setup. Maybe I can get a great one. I have it here. So I think I'll show you. I have it here in my diagram. So this is the kind of setup we're trying to do. So we have the source. It goes through that path here. There's a laser going through that path here, reflects on a mirror, go into a BBO crystal, which splits the photon, the single photon, into 2 part entangled photons. And then the bottom photon goes to a detector here, which goes to a single source photon detector. And the other one goes through a double slit, and then through a diagonal polarizer, and then to a single photon detector. So all this is good. We have a setup. We have many variations of the setup. The thing is always the calibration. So every little details, the mirror is not perfectly aligned. There's too much noise. There's someone the other day there was an alarm like that rang during the night. We need to have these experiments run for hours because it's 1 photon at a time, and it takes a while. It takes like about 5 hours just to record 1 single experiment. And the other day, for example, while the 5 hours were happening, there's an alarm that rang in the lab. So we need to redo the experiment again, or sometimes the table moves a little bit. So a lot of calibrations, a lot of things to adjust, but we're working on it. That's my point. So there's progress. It's just progress that it's hard to share. Like I'm showing these things to you, but there's a lot of work to make this digestible and explainable to everyone. But it's happening. It's happening. That's my point.
Okay, well, Farbod, would you
Hello.
catch us up on
Yeah.
how things are going, and if you've got any assessment on maybe when we'll have a product, at least the first one.
Sure. This is some of so the experimental setup is similar to what David just explained. So I have a similar setup in my lab, it's slightly different. So these are the latest results. As you see here, we have single photons, we have coincidence counts, for example, AB, and also AB prime. So here we are expecting the single ones or the coincidence ones expecting some interference, and we were not getting it. And we have been trying very hard to do that. And I had a visitor, a professor who is a professor of physics and came to my lab for 2 days, experimentalist, who tried to alignment and set up more accurate. But we're still trying to see why we're not getting the interference, and we just get a single kind of curve like that rather than getting the what we are expecting. So again, we are just making changes and trying to see what we have to do, make it better. And at this stage, I don't know why. So I'll continue. So there are some solutions that we have in mind. I don't know, changing the distance, using different type of lens to focus the source, laser source, and so on. So we are trying all of them. And as David said, there are many degrees of freedom in this test in terms of alignment and changing the parameters. That every time we change something and test something, it takes like one overnight, like 12 hours or more or less, around 12 hours every test, until we get something like that. This result, maybe it's just overnight test for 12 hours, as you see. So anyway, so we are just keep trying and trying, but we don't give up.
So you heard it from the guys who are closest to it as it happens on the ground. We are working on it still. Now, in Farbod's case, we're not getting the kind of clear interference pattern that we need. We see a bit of an interference pattern, we can see that, but it seems like it's got a lot of noise in it. And searching for noise in an experiment like this is difficult, because noise, or what I'm calling noise, is not signal. Signal of the particles that will fall in the interference pattern. Everything else is noise, not signal that falls in the interference pattern. And that seems to be overwhelming our results. And we're not sure why. So the way you solve those kinds of problems is you try something and see if it works. And if that doesn't work, you try something else and see if that works. And you try to eliminate variables one at a time. But Farbod says just to take a preliminary look is 12 hours. So it's not as easy to do as it sounded when we first started. But we are making progress, and I hope that all the people out there who helped us with the gathering the money, in the Kickstart process, and everybody else who's interested in these experiments, just has some patience. And as soon as we get a definitive result, not all the results, just a definitive result, trust me, it will be spread all around, all over. We have a website up where you'll see all the details. You'll see, people in the lab doing the work, the betas are taking it. We'll have a lot of information for you. That may come a few weeks after I announce what the result is, because I'm not going to wait for all the pretty stuff to announce the result. I'm going to announce it as soon as I know it. And then maybe a few weeks later, we'll get the pretty stuff that shows the data behind it. But in any case, I'm not going to keep it a secret. Whether it works the way I think or not isn't the point. I'm going to learn something important either way. That's what experiments are for. That's what experiments are for. And I'm very sorry that it's taken us so long, but it is as it is, and you just have to keep pushing on it until you succeed. So that's where we are.
David, did you have anything to add to that?
No, same as them. I'm
Uh,
just looking forward to see the
all right.
result as soon as possible.
Thank you. Farbad,
Thank you. Yeah, thank you. We just we're continuously working. We never stopped.
I know you do. Thank you both, David and Farbad, for sharing your visuals on your work. That was really interesting to see. And thank you, Tom, for allowing me in to give the audience an update on the latest progress. Thank you
Well,
so
thank
much.
you, Donna.
Thank you.
Thank you.